Okay, now let's talk about polygons. Now, we've actually already studied polygons. Anytime you've talked about triangles, studied triangles, you were studying a polygon, a square, a rectangle. Those are polygons. But here's the deal. Let's suppose you've got a line segment and then another line segment, yet another one, and another one. So you've got these 4 line segments. Now, let me, I'll just say we'll label these points A, B, C, and D. This is what we call a polygon. Notice that there are 4 sides. There's the side AB, that segment. There's the side BC, CD, and AD. Those line segments come together to serve as sides for what we call a polygon. Now, we say it's a polygon. First of all, we start off with at least 3 segments, and each of these segments is called a side. And here's the thing. Each side intersects exactly 2 sides, one at each endpoint. So notice, this segment right here intersects this side and this side at an endpoint, okay? So notice each segment has that property. It intersects exactly 2 sides. So see, this intersects this side and this side at 2 points, at the endpoints right there. Okay? When you have a situation like that, you have a polygon, and we call these things, where these sides come together, the intersections, we call those the vertices, the vertex. So here's a vertex at A, there's a vertex at B, C, and D. Okay? Now, if you look down here, we've got a polygon. Notice this one up here was 4-sided. This one is 1, 2, 3, 4, 5. 5-sided polygon. Notice we've got the sides. We've got the vertices. There's a vertex at C, B, A, E, and D. And we've got these sides. Okay? Now, what we want to do, once we get the definition of these polygons, we want to classify them. Now, broadly speaking, we're going to talk about convex and concave polygons. Now, here is an example of a convex polygon, and here's an example of a concave. Now, here's the deal. If you want to talk about if you're talking about a convex polygon, here's what you're talking about. Notice this side right here. Let's just look at this side. Notice the line that contains that line segment, it doesn't pass through the polygon at all. In other words, it contains no interior points. That's what I'm saying. Whereas, look at this one over here. Look at this side of this one. This is a polygon, but notice that this line right here that contains this line segment, it passes right through the interior of that polygon. When that happens, we talk about that polygon being concave. When we have one like this, it's convex. So this one up here, this one is concave, or convex. Okay? So we have concave and convex. In other words, one of the ways you can think of it is if you are standing, if you just walk along a side of a polygon, if you just keep walking, if you will venture into the interior of the polygon and cross over to the other side, you know you've got a concave polygon. Okay? So just keep those straight. We have convex and concave. Now, we also classify polygons by the number of sides. A triangle has 3 sides, and that's something we're familiar with. A quadrilateral has 4 sides. A pentagon, 5. Hexagon, 6. Heptagon, 7. Now, we don't need to remember all of these. You know, the main things you'll see triangle, quadrilateral, pentagon, hexagon, mainly that. And a lot of times you'll see octagon, okay? Of course, we have nanogon, decagon, 10. So there's a lot of them. And, of course, insides, we just talk about n-gon. So you could have 100 side. You could have a 100-side polygon. But we don't have the names that we, at some point we just start calling them n-gons. So 100-gon. Okay. Now, so if you look at these polygons down here, and in example 2, we've got this one. We've got 1, 2, 3, 4, 5. This is a six-sided polygon. So that's going to be a hexagon. This one right here, 4-sided. 1, 2, 3, 4. 4-sided polygon. So that's going to be a quadrilateral. Now this one over here, let's see what this one is. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12-sided. So that's dodecagon. Okay? Dodecagon. If I count it correctly. Okay? Now, let's classify them according to convex and concave. This one is convex. This one's convex. Now remember why it's convex. If we are at any line segment, if we extend it out and make a line, that line does not pass through the polygon. Okay? So I'll come over here to this one. Notice if I extend this side out, it doesn't pass through the interior. If I extend this out, it doesn't pass through the interior. So we talk about those being convex. Now concave, let's see what happens here. Let me extend this line out. That passes right through the interior. If I extend this line out, passes through the interior. So this one right here, this is concave. Concave, yeah. Okay, now, one of the things, something else we need to look at here, there's a couple of terms that we need to be familiar with to further describe these polygons instead of by how many sides and whether or not they're concave or convex. Okay, so we want to talk about these polygons in the following. Let me just erase these lines in here. Now notice this polygon right here has got a little line through each side. Now what that line tells us, and we haven't talked about this before, but that line tells us that these sides are the same length. Okay? So let me see, 1, 2, 3, 4, 5, 6. All 6 of these sides are the same length. So we refer to that as equilateral. Equilateral. Now, also, let's look at this one. Notice that every angle, we have these little curves here indicating all these angles are the same. So this is also equiangular. So this here polygon is both equilateral and angular. When that happens, when all the sides are the same length, all the angles are the same measurements, we say this is a regular. So this is a regular polygon. Now, if you look at this other one, let's look at this other one. Notice that this side and this side are the same because they have one line through them, but this side and this side, they're not. These two sides are the same, okay, this side and this side, but they're not the same as these two sides. So notice that we have one line here, one line here. Those sides are the same length. 2 lines here, 2 lines here. those sides are the same length. So not all the sides are the same length. So this is not equilateral. And also notice that this angle has two little curves. This angle has two little curves. So those angles have the same measure. This angle up here has one curve, and this one has one curve. So those angles are the same. But not all four angles are the same. So this is not equiangular. So it's neither equiangular nor equilateral. Okay? So we can't classify it that way. Now let's look at this other one. Notice that all the sides are the same. So we can definitely say this is equilateral. So this one is equilateral, but it's now one of the things I didn't emphasize earlier, or I didn't even mention it, when we talk about a convex, when we talk about a regular polygon, I left out part of the definition. A regular polygon needs to be convex. So a regular polygon is a convex polygon that is both equilateral and equiangular. Now this one is not convex, this is concave, and it is equilateral, but it doesn't meet the definition of being a regular polygon. So this is not a regular polygon. So remember, a regular polygon has to be convex and equilateral and equiangular. Okay, now let's look at an example here of how we could use some of this stuff. A table is shaped like a regular hexagon. Now remember, a regular hexagon means all the sides are the same length. All the angles have the same measurement. Okay, now what they've done is they've expressed the length of the side here as 3x plus 6 and the length of the side here as 3x minus 2. Now, if this is indeed a regular hexagon, and it is, then that must mean that 3x plus 6 is the same as 4x minus 2. These are the lengths are the same. So we want to find the length of each side. Well, let's look here. Let's see, let's solve this equation. If I subtract 3x from both sides, I get x minus 2 equals 6. And then if I add 2, I get x equals 8. You can see we did the work up here. So if I want to know the length of a side, I can just go back to either one of these. I'll do 3x plus 6. If x is equal to 8, I've got 3 times 8 plus 6. Let's see what that's going to be. That's going to be 24 plus 6 would be 30. So there it goes. So it looks like the length of the side is 30 inches. Okay, there you have it. Now I've put the assignment at the end, so don't forget that one.